Okay guys, so today we are doing some, well, geometry from the Polish MO. That's gonna be just about awesome, so let's do it. Point O is the circumcenter of an isosceles triangle ABC with AC equal to BC greater than AB. Point M is the midpoint of AC. The circumcircle of the triangle AMO intersects the segment BM at the point X other than M. Prove that CX is equal to double MX. Lovely. So, well, first of all, what the hell's going on here? How do you draw it? So, let me draw it out for you guys. We are given a circle with the center O, and we've got a triangle that's going to be isosceles that we have inscribed inside of this circle. This is going to be our triangle ABC, so hopefully it will look something like this. Yeah, it sounds too bad, I think. Lovely. Now we are supposed to mark the center. Is it the center? Kind of, yeah. And the midpoint of this side AC. So those are gonna be my vertices A, B, and C right there. Okay, now I'm supposed to draw myself a triangle AMO and also circumscribe a circle around it. It will look something like this, so I have to make the circle a little bit bigger. Now it's awesome. And now, well, now the fun part begins. I'm supposed to connect myself the point M to point B, and this line segment is going to intersect the smallest circle in the point I'm gonna call X. And now I'm supposed to prove that point X lies twice as far from C than it lies from M. And so I'm supposed to prove that this guy there, so the MX, is, well, 1/2 of the CX. So let me just write it somewhere here. I would like to prove that CX is equal to double MX. Lovely. So how are we supposed to do it? Well, first of all, I would like to make my rubber a little bit smaller and take this point O a little bit more to the left so it doesn't intersect with CX. And now, well, first of all, we know that this triangle is going to be isosceles. Yeah, and so whenever I will drop the height from the vertex C, it is supposed to go through the point O. And maybe, you know, my drawing is not perfect. It's even shitty, I say, but I'm going to fix it in just a moment. Yeah, so this is supposed to be an isosceles triangle, and we know that in isosceles triangles the height going from the vertex C, so the vertex where those two equal sides intersect, is going to first of all divide our base in half, and is going to, well, intersect the base at the right angle, and also is going to be crossing the circumcenter, so our point O perfectly. Now, we know that this triangle is going to be isosceles, so let me mark two angles are going to be equal here as alpha. So those 2 points, those two angles are going to be alpha. And thus we know that the angle ACB, so this guy right over there, is going to be equal to 180 degrees minus double the alpha. And so this angle there between this AC line and the height is going to be 90 degrees minus an alpha. I'm going to write it right there, 90 degrees minus an alpha. That's just going to be half, because the height also bisects the angle that's right at the vertex where those two equal sides intersect. Yeah, lovely. But now, one more thing. We know that M is going to be the midpoint of AC. And, well, what's the definition of the circumcircle? Well, we know that this is the point where all of the bisectors of the sides meet. And so now, if I were to, well, draw myself, or I actually have already drawn a line segment connected M and O, well, it is going to be at the right angle to the side AC, because this is just the bisector of the side AC. But this will mean, by some angle chasing, that this angle there, oh no, I didn't want to destroy everything, so it's going to be my O, and now this angle there is going to be my alpha. But, well, as this triangle right there is actually going to be isosceles, because M is the midpoint of the side AC, and those two angles here and here are gonna be 90 degrees, we will get that this angle right there is also going to be alpha. Well, that's pretty neat, and you'll see why in just a few seconds. So now I would like to introduce another trick. I would like to take myself another color. Let me choose something nice. Let's say it's going to be purple. And I would like to extend this straight line BM such that it will intersect with the big, huge circle at the point H. And I would like to, well, let the magic happen. So let me connect the points HA. Yeah, it's going to be HA is going to be HC right there. I'm going to connect A to the point X, and I have already connected point X to the point C, but I'm going to do it once again. So as you can see, if now, okay, now it's perfect. Now, if I were to prove that this figure I've got there, so maybe I'm gonna highlight it, yes, I'm like this. So this figure right here, this quadrilateral, is actually going to be a parallelogram that consists of two isosceles triangles, those two triangles there. Well, if I manage to prove that those two triangles are isosceles, well, then I'm pretty much awesome. I mean, if I manage to prove two things. If this is a parallelogram, then I know that those two diagonals will intersect in the exact middle, yeah? So they are gonna bisect each other. So then I will absolutely in 100% know that this line right there, this segment HM, is going to be equal to the segment MX. And also then I'm going to know if those two triangles are actually isosceles, that this segment XC is going to be double MX because it's just a half of HX, and HX is going to be equal to CX. So let's go on and do it. Let's try and prove it. So how are we supposed to do it? First of all, we see a pretty interesting fact. So what kind of an arc is this angle there based on? Yeah, on this arc right over here. But is there any kind of an angle that's also supporting this arc? Well, this alpha there, yeah? Okay, that's pretty interesting. So we see that this angle here is going to be an alpha. Lovely, because now, well, what is this angle here? Well, this is supporting this arc there, but this arc is also supported by this angle here, which is just going to be 180 degrees minus double the alpha, as we know, because ABC is an isosceles triangle. Yeah, and so this angle here is going to be 180 degrees minus double alpha. But now, if this angle here is alpha, this is 180 minus double alpha, well, and we know that all of the angles have to sum up to 180 degrees, we know that this angle there is also going to be an alpha. That's awesome. We already have one of those triangles set in place, so we know that this is going to be an isosceles triangle. It's got, two of its angles equal. Lovely. But now let's go for the second one. How are we supposed to prove that it's going to be actually nicely isosceles? So first of all, what is this angle here? Well, it supports this arc right over there. Let me just get rid of this orange line, this orange arc. Well, this arc is also supported by this angle, this CAB angle then. So, well, what is the measure of CAB? It's just alpha. And so we know that this angle here is also going to be an alpha. Pretty lovely. But well, now we have one more lovely thing to go. You see, those two angles are, I don't know, how was it called in English? It's not adjacent. Shit. Transversal. It was transversal. Or I hope it was transversal. Yeah. So those two angles are gonna be equal. I'm sure about it. Yeah. So I'm just gonna get rid of this M. I'm gonna write it right here, and I'm gonna say that those two angles are going to be nicely equal to each other. But now the magic happens again. So, well, we see that we've got an alpha there, an alpha here. This angle, this green angle here, and this green angle there. And so if we have two triangles, and two of the angles are respectively equal, then the third angle in each triangle is also going to be equal. And so those two angles, this guy that I'm gonna, I don't know, denote with this with this light pink there, this guy and also this guy, they will have to be of equal length. But, well, now we have that those two triangles are similar because, well, they have the same angle measures, but they are not similar. They are actually congruent. And why is it so? Because they share this, I mean, they don't share any side, but they have two sides of equal length that are AM and MC. Those are of equal length because M is the middle point of AC. And so we've got that those two triangles are actually congruent. But what does this thing also tell us? It tells us that HM is equal to MX. And so we actually finally get that the diagonals of this quadrilateral AXCH are bisecting each other, and so this is indeed a parallelogram. If this is a parallelogram, yes, so I'm gonna even write it down, yeah. So AXCH is a parallelepiped. Is a parallelogram. Yeah, lovely. And now, well, what do we get out of it? We know that those two angles, this guy and this guy, will have to be equal because this is a parallelogram. And so, this angle there, I'm literally running out of space here, this light pink angle there is going to be 180 degrees minus double the alpha. I know that my 2 looks like my alpha, but let's just pretend we don't care about it. Yes, so this is going to be 180 degrees minus double the alpha. And now, well, this means that this angle here is going to be 180 degrees minus 180 minus double alpha, and minus an alpha, that's just alpha. And so we've got finally that this triangle here is also going to be isosceles. And I know this drawing is just a mess, but just, you know, keep with me here. I'm going to make it a little bit more. I'm going to just get rid of some stuff that is unnecessary here. For example, this guy is unnecessary. This is unnecessary. I don't need it. I don't need it. I will make it better. Yeah, now it's all better. Okay, so we have that this is 180 minus double alpha, this is also 180 minus double alpha, this is an alpha, this is an alpha, this is an alpha. And so we've actually finally got that those two triangles here and here are isosceles, and this entire thing, this entire quadrilateral AXCH is going to be a parallelogram. And thus, we see that this side CX is equal to this side HX of the triangle HXC, but you see MX is just half of, oh man, MX is a half of HX, but that's equal to a half of CX. And so we've got that CX is equal to double MX, which was exactly what we were supposed to prove in this problem. I hope you guys enjoyed it, and see you next one. Bye.